We're going to look at a problem from JEE Advanced 2023. Now this is an algebra problem, and here we're given this sort of summation, right? And let's go to the problem. Now we have this kind of pattern here with r digit 5, and there's 7 on both ends. So the total is going to be r plus 2 digit number. And then we're going to have the summation here from 77, 757 up to there is this 98 of 5s. Alright? So this summation can be expressed in terms of this fraction here, and we try to find out m plus n. Alright, so this just pure algebra problem. So it is good to look at this term here. How can we evaluate the value here? Now we're going to start to ask the question, if we have a bunch of 7s and if there are n digits, what is the value here? Right? Of course, we can start with 1 with a bunch of zeros. How many of them? N of them. We all know that that's 10 to the nth power. Alright? So if you minus 1, and you become a bunch of 9s. So 10 to the n minus 1 is going to be a bunch of 9s. How many of them? It's n of them. So for 7 here, it's going to be divided by 9, and then this becomes a bunch of 1s and times 7. So it's going to be, so this is going to be 7 over 9 times 10 to the nth power minus 1. Alright? So now, once we have that, how about these terms? Okay? How do you write in this sort of a algebra form? What you can do here is that you notice that this is actually, if you have, let's say this time we have n7 with a bunch of 5s here in the middle, and let's say there's r of them, and 7. So you notice that that can be changed into a bunch of 7s, right? How many of them? It's going to be r plus 2 7s, and then minus, right? Minus here, in order to get 5, you have a bunch of 5s, bunch of 2s. How many of them? You're going to have r of them, and then followed by a 0, right? Because this is a digit here. Okay? So you can plug in the formula here now. So this one would equal to, the first term, you know that that's 7 over 9. 10 to the r plus 2's power minus 1. And then you minus 2, of course, we know that using the similar logic, we know that for a bunch of 2's, we can just change this to 2, right? So in other words, here we're going to have 2 over 9, yeah? And 10 to the r's power minus 1. However, you're going to have a 0 at the end, so you have times 10. Let's change this to 20, right? That's times 10. Alright, so let's simplify this algebra here. We know that 1 over 9, we'll take it out. And the first term is going to be 7 times 10 to the r plus 2. And then minus 7. And for the second one, it's going to be you have 20. And then 10 minus r. Yeah. So what we can do, maybe you're going to fold this 20 here, 10 here, into the power. So it becomes 2 times r plus 1's power, right? And then here you have a minus 1 times 20, minus minus become positive. So that's positive, and then that would be positive 20. Yeah? So further combine the terms here. Now these two terms here, the smaller one is r plus 1, so let's keep that. And then this becomes 70 here, okay? And minus 2, this becomes 68, okay? So this becomes 68 times 10 to the r plus 1's power, and then we have minus 7 and plus 20, that's plus 13, okay? So that's the form here. Now, let's do some sanity check. What if r equals 0? So, when r equals 0, the left-hand side is 77, and the right-hand side is going to be 1 over 9. And 0 here is going to be 680 plus 13. Yeah, so that's 693 over 9. That's indeed 77. Okay, so it looks like we did not make algebra mistakes. Okay, so now let's go back to the question. Once we have this formula here for the terms, right? We have this formula here for the terms. Here we're going to do the summation from when r equal to 0 up to 98. So we know that the s is actually equal these terms with summation here, right? With the summation for r equals 0 to 98 of 1 over 9. Yeah, we have 1 over 9. We're going to take it out. 1 over 9. Yeah. And then here is going to be a 68 10 to the r plus 1's power plus 13. Okay. So use the geometric sequence formula. You can further simplify this, right? So let's okay, I don't like this 1 over 9 here, right? This over 9 is kind of I don't want to write it every time. So I'm going to say 9 times s, okay, equal, and this is constant terms, and the total term is going from 0 to 98. The total is 99, so that would be 13 times 99, the constant term first. And then, since we get rid of this 1 over 9, this is just a 68 times some geometric sequence, right? So let's put a 68 first. And geometric sequence formula here is the first term. Okay, the first term here, when r equal to 0 here, r equal to 0, the first term is going to be 10. All right, the first term, minus the final term times the ratio here. Common ratio is 10, right? And the denominator is 1 minus 10. The final term is when r equal 98, this become 10 to the 99th power. Okay, so 10 to the 99th power, right? So what you can do is you can further derive. So let's swap the sign here, right? Because this is a negative number. We don't want to work with negative, we want to work with positive number, right? So what you can do is to swap this, right? So change this to 13 times 99. And plus, that's going to be 9, right? It's going to be 68. That's going to be 10 to the 100th power minus 10. Okay? So that's what we have. And if you want to get rid of the fraction, let's further do it. 81s would be equal 13 times 9 times 99. Yeah? And plus 68 times 10 to the 100th power and minus 680. Okay? Now, what is the other form? Here we are given that this whole thing s equals this one. Okay? So the right hand side is going to be, there's 99 of them, r equal 99. So the right hand side equal s, this term plus a number integer divided by n. Okay? And of course, we're going to get 9 here, make it easier, and this is 9. Okay? Alright, so let's see, and the whole thing must equal to s, right? So what we have is we're going to turn this to the equation here. 9 s would equal to 68 times 100, 10 to the 100th power, plus 13, right? Plus 9m. Yeah. So, and here, of course, we want to compare these two equations here, right? This one versus this one. Oh, they didn't term the matches, okay? So maybe you want to make them equal to each other. In other words, maybe n would equal to 9, right? So if n equal 9, So this would be H1s, the two term would equal. Then what we can claim that 68 from the second equation plus 13 plus 9m would equal the other one, which is this term. Let's write this first. So that's going to be 68, 10 to the 100th power. Yeah. And then plus this number here, 13 times 9 times 99 minus 680, right? So what we can do is we have this term cancels. Yeah, so we have this term would cancel, right? This term would cancel. And what we can further combine the terms here, we're going to have 9m, right, is going to equal to 13 times 9 times 99 minus 680 and then plus minus 13. Now you can divide 9 by both ends, so m would equal to 13 times 99 minus this whole thing divided by 9 is going to be 77, as we noticed earlier, right? So earlier we did this math here, right? This is exactly 77. Okay, so now you do some math here, yeah. So 13 gonna be 1300 minus 13, right? So it's 1300, yeah, minus 13, which is minus 90 here, right? Here's a trick to calculate this, right? Because this, you can do a mental math, but it's easier to say the 1300 minus 13. And minus 13 with this, that would be minus 90, easier to calculate, right? And then we try to find m plus n equal 9, right? So that's will be 1300, right? Minus 90, yeah, plus n, which is 9. Okay, so that gives us 112, 1, 9, I think. Yeah. So that will be final answer here. Now let's review what are the tricks. I think this is just simply to test your algebra skills. Right? Important to know this, right? And then from here we know how to express a bunch of nines. From a bunch of nines we know how to express a bunch of sevens. And for this pattern it's easier to decompose into two terms and have this expression here and simplification, and that's the thing we're going to use, right? So we just plug in the summation here using geometric formula here, and we do this comparison. The key observation is that you want to cancel these big terms, and then that's the answer. All right. I hope you enjoyed the video, and in the meantime, please like, share, and subscribe to the channel.